Greetings, students. This is the first set of notes in the Astronomy unit. These are notes on the universe. The universe is everything contained in all of outer space. The universe is huge. Using SI units, the Earth would be 880 septillion kilometers in diameter, I think. Well, 88 with a whole lot of zeros on the back of it. Outer space is so big, we use special units called light years to measure it. Light years are used to measure extremely long distances. The universe is 93 billion light years in diameter. Light moves quickly. The speed of light is about 300 million meters per second. A light year is the distance you would travel if you spent one whole year traveling at that speed. The next closest star to our solar system is Alpha Centauri. It is 4.3 light years away. If Alpha Centauri were to explode in a supernova, we would find out 4.3 years later because the light from the explosion would take that long to reach Earth. Do you think we could ever travel there? Answer yes or no on your notes. At current spacecraft speeds, it would take thousands of years to reach this nearest neighbor solar system. The origin of the universe. The best theory for the origin of the universe is the Big Bang Theory. The Big Bang Theory states that the universe began in a very hot, very dense state and expanded rapidly 13.8 billion years ago. Now, of course, nobody was there to witness this, but we do have some evidence. The best evidence for the Big Bang is the observable fact that the universe is still expanding. Any light that is moving away from the point of observation will exhibit a shift towards the red side of the visible spectrum. That's known as redshift. Any light that is moving towards the point of observation will exhibit a shift towards the blue side of the visible spectrum. That's known as blue shift. So you can tell by the tint of a light whether it's moving towards you or away from you. Using sophisticated technology like the Hubble Space Telescope, scientists have documented that all galaxies exhibit redshift and are therefore moving away from us. Here's some pictures of galaxies exhibiting redshift. But what's a galaxy? Galaxies are collections of hundreds of billions of stars. All galaxies fall into one of three types. They can be spiral, elliptical, or irregular. Our solar system is located in the Milky Way galaxy, which is a spiral galaxy. Do you think this is a real picture of the Milky Way galaxy? Well, it can't be. The furthest we've ever sent a probe or any kind of device is just to the outer reaches of our own solar system. In order to get a real photograph of the Milky Way from this distance, we would have to send some sort of device with a camera on it way further than we've ever sent anything. Here's a picture of part of the Milky Way in the night sky. If you live in the city, you don't really see this many stars, but if you go out to the country, you can see lots and lots of stars, including this kind of stripe across the sky sometimes, which is part of the Milky Way galaxy. Okay, so we did the origin of the universe. Now we're going to talk about the origin of the solar system, so like the sun and the planets. The best theory for the origin of our solar system, and all solar systems, is the solar nebula theory. A solar nebula is a cloud of dust and gas in outer space. The solar nebula theory states that all stars and solar systems form when a solar nebula condenses. And here is a diagram that shows a life cycle of a star. All stars begin as a stellar nebula, and they can take two pathways. One of them is for massive stars, and one of them is for average stars. And all stars, when they die, either become a black hole, a neutron star, or a white dwarf. Star life cycles can take two different paths depending on how big the star is. As a star goes through its life cycle, its brightness and temperature changes. We can track those changes using an HR diagram. HR stands for Hertzsprung-Russell. And this is what the diagram looks like. It plots temperature versus luminosity. Luminosity is another word for brightness. So every star can be plotted on this Hertzsprung-Russell diagram based on its current temperature and brightness. Brightness, also called absolute magnitude or luminosity, is shown on the y-axis, that's up and down. And the higher the star is on the diagram, the brighter it is. Temperature is on the x-axis, but beware, it's backwards. The highest temperatures are on the left, where you might expect them to be on the right. Our sun is an average star on the main sequence. So in this diagram, our sun's right in the middle. Our sun is currently a main sequence star. In approximately 5 billion years, it will run out of hydrogen fuel and become a red giant. Ultimately, it is destined to become a white dwarf. Elements. All elements in the universe are produced inside of stars. Most stars are using fusion to turn hydrogen into helium. When they run out of hydrogen, fuel, they start fusing the helium into even larger elements like iron and nickel. Every element that can be found on Earth was once inside of a star. Here's an interesting picture. This is actually the only known photograph of a black hole. Black holes are a great amount of matter packed into a very small area. The result is a gravitational field so strong that nothing, not even light, can escape. Black holes are left behind when a very big star dies. Supermassive black holes are predicted to exist at the center of most galaxies.